Hello, this is Mrs. Boots, and we're going to look at composite functions. Composite functions are just a shorthand notation for how we've done functions in the past. So we're doing all the same things that we've been doing. We're going to add, subtract, multiply, divide, evaluate, and solve. Okay, so all of those same things. The trick is looking for the operation. The operation, yes, the operation. And I'm not talking about medical procedures. We're looking for a symbol that tells us what we need to do. So in example 1, I see this notation. What does it mean? Notice the symbol. The symbol is a negative, a subtraction symbol. So guess what? We're going to subtract. Okay? With subtract, does the order matter? Yes. So which letter comes first? F. F comes first. So I'm going to write my F function first. So I have the 2x squared plus 4x minus 6. All right? We're subtracting. We just figured that out. So we're going to pick up a big old minus sign with a parenthesis. The letter G comes next. So we write the G function inside the parentheses. My G function, really simple, is just x minus 1. Now guess what we're going to do? Yep, you got it. We are going to distribute this negative sign to everything inside. These terms at the beginning, we're just going to write them down. They haven't changed, so we keep them the same way it is. Does this look familiar? It should. So we get negative x plus 1. Now we're combining like terms. Combine like terms. I've got x, and then I've got some constants. But I only have one x squared. Always start with the highest exponent. 2 is x squared. 4 minus 1 gives us 3x. Negative 6 plus 1, negative 5. That's it. That's it. The only new part is this beautiful notation. That's the only new part. The rest of it, same old, same old. What are we doing in example 2? Yeah, it's not that hard. We're going to add this time. So I'm writing down the same two functions, only this time we're going to add them. So I have 2x squared plus 4x minus 6. And if I get really creative, I can just add them vertically, okay? That gives me 2x squared plus 5x minus 7. Is there a huge difference between the answers for the add and the subtract? No, not in this case. Why? Because the G function is so small and so simple, we don't have a big difference unless we add or subtract. If it's a different function, the differences in the answer will be more pronounced. Example 3. What are we doing? Well, I don't see an operator. I don't see anything in there that's a symbol. No minus sign, no plus sign. Okay, so which operation can we do where we just don't have any symbol? Yeah, it's a multiply. If there's nothing there, you multiply. That was really messy, sorry. Okay, so we're going to multiply. Big old capital N there. So, multiply what? What comes first? Does it matter? Does the order matter with multiplication? 3 times 4, 4 times 3, it's still 12. It doesn't matter. So I'm going to put the small one in front just because it makes it easier to go in and do the distributing. So I'm writing G in front, the x minus 1, and then I'm going to write my x, or my f. 2x squared plus 4x minus 6. Okay, so I've got to distribute that x. First term, distribute. All 3 terms. Everything in that trinomial. Okay, so x times 2x squared, what do we get? We get 2x cubed. X times 4x plus 4x squared. And then x times negative 6 minus 6x. Okay, so we got that one done. Now for the negative 1. Distribute the negative 1. Again, it's like kids and cookies. Everybody gets one. So negative 1 and 2x squared gives me negative 2x squared. You knew I was going to line them up underneath each other, right? Yeah, because I don't like writing them out all over the place and then trying to figure it out. It's easier. Negative 1 plus 4x or times 4x minus 4x. Negative 1 times negative 6 plus 6. Do you have to write them one under the other? No. If you want to write it out in one big long row, go right ahead. That does not hurt my feelings. As long as you combine all your like terms correctly, it's no big deal. The 2x cubed is by itself. There's only one of them. I have 4x squared minus 2x. That gives me plus 2x squared. Negative 6x and negative 4x gives me negative 10x. And that poor little lonely constant of a 6 is by itself. So we did subtraction, right? We did addition and we did multiplication. Guess what else we're going to do? Yep, you know they're coming. Example 4. Which operation are we performing? Well, the line in the middle should tell you. I have something on top of something. Yeah, it's a division problem. Okay, so we're going to divide. Which function goes on top? F of x. So we write that on top. No big deal. 2x squared plus 4x minus 6. The functions on the bottom is the g, x minus 1. Now we have 3 different options. We can do long division. Because this is an x minus 1, the leading coefficient is a 1, I could do synthetic division, or we can factor and cancel and write what's left. Your choice. It doesn't matter which method you choose, as long as you get the job done. Okay? I'm going to factor it, just to show you that it can be done, because most students won't do the factoring. I noticed that in my numerator, every single term is even, which means I can divide it by 2. So I'm going to pull a 2 out and see what's left. When I divide it by 2, I'm left with x squared plus 2x minus 3. I think I can handle that. Those are small numbers, right? Do I have 2 numbers that will multiply to give me 3 and subtract to give me 2? Yes, we do. Well, that's 3 and 1. Keep that 2 on the outside, please. Don't lose him. X's are at the front. There's a 3 and a 1. What are the signs? Middle term has a positive, so the big number has to be positive. Because we subtracted, the other term has to have a negative. That's completely factored. I'm going to put parentheses around this one. I already looked at it. It's a binomial, but the power is 1 and there's no GCF. So what cancels? X minus 1s. Isn't that beautiful? So now we write down what's left. What's left in this? 2 and an x plus 3. They're both in the numerator, so I keep it in the numerator. There's nothing in the denominator, so I don't have to write that it's over 1 or that it's a fraction. That is my simplified polynomial for this division, for this composite. Remember, we always want to simplify it, because if you ever have to plug it into a computer program, you want the computer to do the least amount of processing as possible, because then you can accomplish more faster. It moves faster when you don't give it complex stuff, just like us. Example 5 and 6 are the ones that may confuse a few folks. All right? So if I cover this up, I have f with something in parentheses, right? I'm plugging something into that function. It could be a number, it could be a letter, it could be an emoji. It doesn't matter. I'm plugging it into the function. Okay? What am I plugging in? I am plugging in an entire another function, but it's okay. We can do it. So the G is being plugged into the F, right? So I'm going to I start from the outside and I work my way in, okay? The outside letter is the F. So I go to my F function, but instead of X's, because I know I'm plugging something in, I'm going to put parentheses, okay? Everywhere you see an X, put parentheses. So I have a 2 parentheses squared plus 4 parentheses minus 6. Well, that was easy, right? Now we figure out what we're plugging in. We're plugging in G. What is G? G is x minus 1. So inside the parentheses, everywhere I have parentheses, I'm going to put an x minus 1. Well, that was easy, right? No big deal. Okay, well now we get the tricky part, right? Because we actually have to simplify it. What comes first? Do I distribute the 2 or do I square it? Got to square it first. The 4 I can go ahead and distribute. All right? So let's go in and do that. So the 2 is going to stay out front. And inside I've got x squared minus x plus 1. Whoa! How did we do that? Where did all these x's come from? I only see 2 things, Mrs. Boots. Oh, we forgot. Stop the press. Hold on. Let me go back. Remember, if it's written to an exponent, to a power, I have to write it that many times. So x minus 1 squared is x minus 1 times x minus 1. If I'd had it cubed, I'd have to write it 1, 2, 3 times. If it was to the 4th power, I'd write it 4 times, okay? We write it that many times, we multiply it out. When you get good enough, you can do it in your head. You don't have to multiply it out, right? I did it in my head, and I shouldn't have done that to you. So we wrote it in there. So if you miss that, go back and multiply it out. You'll get the same thing, guaranteed. Okay, now we're going to distribute this 4. Can we handle that? 4 times x plus 4x. Okay, 4 times negative 1 minus 4, drop down the 6, minus 6. Are we ready to combine like terms? No, we still got to distribute this 2 out front. It has to go to every single thing inside the parentheses. So I'm going to have 2x squared minus 2x minus 2x plus 2. Dropping down that 4x. I'm going to go ahead and combine these. Is that okay with you guys? Just going to combine them. Minus 4 and minus 6 gives me minus 10. All right, well, we're not done combining, are we? I got a little ahead of myself. Look at that. We got some x's we can combine, and then we got another constant in there that we're going to have to combine. But that's okay. Bring the 2x squared down. Now what do we have? Minus 2 plus 4. Oh, that's gone. So no x's. They're all gone, okay? Plus 2 minus 10 is minus 8. All right. This looks a lot easier than that does. Now we're going to do it the reverse, right? What are we doing? We're taking G and we're plugging in F. We're taking G and plugging in F. So I look at my G function. It's just x minus 1. Not a big deal. Everywhere there's an x, parentheses, then I put minus 1. What goes inside the parentheses? Yeah, the f function. That's going to be written inside the parentheses. So I have 2x squared plus 4x plus, minus 6. Make sure you copy it down correctly. Don't do a Mrs. Boots and get it wrong. All right. Do I have anything squared? Nope. Do I have anything to distribute? Nope. Do I have anything? Well, we got some like terms, right? I see a negative 6 and a negative 1. So let's combine the like terms. So I have 2x squared plus 4x minus 7. All right, so that's the simplified polynomial for that composite function. Compare the two composite functions. All right, look at all the work we had to do on this one. We had to square things and distribute and then combine like terms 2 or 3 times. And then we got this answer. Number 6, there wasn't any squaring, wasn't any distributing. We just combined a few like terms. Very different simplified answers, right? Very different. It matters which one we're plugging in and which one is on the outside. It tells us how much work we got to do, and it affects our final solution. The only thing these two have in common is the 2x squared. Now we're going to show you how to do the plugging in, the evaluating, where there's numbers involved. Now for example 7. Notice we're doing the exact same thing. We're plugging a function into a function. Only this time we mixed it up. Instead of an x, we have a 2. What do? Well, remember how when we have a function combined with a function, I start with the outside and I work my way in? Well, when I have a number, I start with the inside and I work my way out. Let me explain. I'm going to take the 2 and plug it into g first. Okay? So where's my g? My g of x equals x minus 1, right? So I want the g of 2. So everywhere there's an x, I'm plugging in a 2. G of 2 is 2 minus 1. What is 2 minus 1? Well, that was kind of anticlimactic, right? It's just 1. Okay, so now that we have that, we're going to take that answer and plug it into the f. So see how we're building. It's like those little nested dolls where you got one inside the other, and you put them together. So now we come in, we have f of, let me do the f of x function so we can clearly see where we are plugging these in, okay? And so I need to plug in the 1 everywhere I see the x, okay? So I'm going to have f remember, we write in parentheses everywhere you see an x, and now I'm going to plug in my 1. So I have f of 1, 2 times 1 squared plus 4 times 1 minus 6. Okay, 1 squared is 1. 1 times 2 is 2. 4 times 1 is 4. Minus 6. Okay, 2 plus 4 is 6. 6 minus 6. Yeah, 0. That was kind of anticlimactic, the whole thing. I did all that work for a 0. Well, economically, that tells you something, right? If you have one product line represented by this function and another product line represented by another function, you know you're making money over here and you're losing money over here, but you're wondering, am I making money overall or am I losing it overall? You don't have to wait 3 or 4 months to find out. Guess what? You're breaking even. It's a 0. It's a wash. So whatever money you made, whatever profit you made doing this product, you're losing the same amount doing this product. So you need to fix something over here, okay? Let's look at number 8. Same thing. Only this time, I'm plugging the number into the f function first. So let's write down our f function. I'm just going to go ahead and write it with parentheses. 2x squared plus 4x minus 6. Okay? What are we plugging in? Negative 3. Now, let's go through and simplify. Okay, negative 3 squared is 9. 9 times 2 is 18. Yeah, that's a negative 12. 4 times 3, and then minus 6. So I have 18 minus 18. Wow, we did a real good job of picking good numbers on these. So f of negative 3 equals 0. Are we done? No, we're not done. We now have to take that 0 and plug it into the g function. Okay? So I'm going to write my g function down. Remember to put parentheses everywhere there's an x. So I'm going to take my f of 0 and plug it in. So I have a 0 and a 0. So what's my answer? Yeah. Okay, so I should have written it as g of f of negative 1, and that's equal to, or negative 3 is equal to negative 1. So back here on this problem, we're going to change this. I need to write this differently. I should have written it as f of g of 2. All right, so I'm clearly stating what it was I was looking for and that I found that solution. So in example A situation, if we're talking about two product lines, guess what? We're losing money. It's not a good thing. We need to really fix something on that.